Well, let's start here in problem number 1. What we want to do is we want to find the area of this rectangle. So we have a formula for it, and the formula for the area of a rectangle is A for area equals length times width. And in our rectangle, we have a length of 37.8 centimeters and a width of 19.5 centimeters. So when we multiply here, we're going to multiply 37.8 and 19.5, and that gave me 737.1, and now we've got centimeters times centimeters. That's going to be centimeters squared. So there's our area, 737.1 square centimeters. And in number 2, we've got a square with this length on a side, so the square is just like a rectangle. We're still going to write this as area is length times width, so we're going to get 66.7 kms times 66.7 kms. So we're going to get our area to be 4448.89 km squared, square kilometers, but we're asked just to round to the nearest tenth. So if I round to the nearest tenth, there's a tenth. That's bigger than a 5, so I'm going to round this up. So if I round it up, I'm going to get the area being 4448.9 square kilometers. What we've got now in number 3 is a parallelogram with these dimensions, and we're given, now it's in the book here, but the area of a parallelogram, there's a bunch of area formulas in the book, is the area of a parallelogram is given by the base times the height. You know, does that seem reasonable here? What if we took this little triangular region off and just cut it off and moved it right over here? Then we'd have a rectangle, and a rectangle would be the base times the height. So the formula should make sense. And in our case, we're going to have that the area is equal to the base, 10 inches, times the height, 13 inches. So we can multiply those, getting 130 inches times inches is square inches. Now, in number 4, we've got a rhombus. And a rhombus is a parallelogram in which all sides have the same length. So it's a parallelogram, so we're going to use the formula for a parallelogram. And that we just used in number 3. It's just the base times the height. So we are going to get that that area is 17 meters times 11 meters. So that area is going to give us 187, m times m is m squared, 187 square meters. Off to number 5, what we have is a triangle with these dimensions, and the area formula for a triangle is area is equal to 1/2 the base times the height. So let's put our numbers in here. We're going to get 1/2 the base, which is 10 inches, times the height, 30 inches. Now half of 10 is 5, so we'll get 5 inches times 30 inches. So we're going to get the area of this triangle is 150 square inches. In number 6, we're given a right triangle. Right triangle meaning we have a triangle with a 90-degree angle here. And we're given that the measures of the legs, here's the legs, are these numbers. So we have a triangle. Now, if it's a right triangle or any triangle, it doesn't matter. The area formula for the area of a triangle is area is 1/2 base times height. So we're going to get 1/2 the base, which is 212 centimeters, times the height, which is 149 centimeters. Now, I did this on my calculator. To make this computation, here's what I did. I multiplied these two numbers here first, and that gave me this, that the area is now going to be 1/2, and what I got was 31588, now, right, square centimeters. And then I just divide this by 2. And I ended up with this. That area is 15, I'll put a comma for 1,000, 794 square centimeters. In problem number 17, we're given a triangle with these sides of length 17, 10, and 12. So we're not giving us a right triangle. We really don't know the height here, so I can't use base times height. But there is a formula we can use, and that formula is this, that the area is going to be the square root of s times s minus a, s minus b, s minus c, square root of all that. And here's what the a, b, and c are. In a triangle, if this is a, b, and c, so in our case, we're going to have the a is the 17, the b is the 10, and the c is the 12. And what about this s? What is this s here? Well, it turns out then in this formula, s is equal to, add up the sides, a plus b plus c, and divide by 2. So this is called the superperimeter. So I'm just going to add up the sides, lengths of the sides, divide by 2. So in our case, a plus b plus c will be 17 plus 10 plus 12. So let's do all this. So we're going to get s equals, all right, we're going to get the 17 plus 10 plus 12 all over 2. So this is equal to, we'll get 39 over 2. And 39 divided by 2, we're going to write as 19.5. So there's our value for s. Now let's substitute this s, our a, b, and c, right, a, b, and c, into our Heron's formula. So here we go. I'll do it up here. So the area is going to be the square root of s, 19.5 times, now this says s minus a, 19.5 minus one of these sides. So how about if we do this? This would be 19.5 minus 17, and then s minus b, that's 19.5 minus the 10 times s minus c. The 19.5 minus the 12, close that off, take the square root of that whole thing. So I multiplied all those together, and I got this. Area is going to equal, now I got 3473.4375. Then I took the square root of that number, and I got that the area is 58 point, now the decimal just keeps going, 9358 ... But the problem tells us to round off to the nearest tenth. So there's the tenth. I look to the right, that number is below 5, so I'm just going to round off. I'll drop all these digits and write the area here as 58.9 square units, whatever the units happen to be. So what we've got here in number 8 is a trapezoid. Now, there is a formula for the trapezoid. It's listed in the book. It goes like this, that the area, right, here's the area formula. The area for a trapezoid is 1/2 times the height, and then in parentheses, we're going to add these together. We're going to add the two bases, say base 1 plus base 2. So I'm going to draw a picture of what's happening here, where all these numbers are. Here's a trapezoid. Here's the height, right? That's going to be height. So that's the h in the formula here. And then we have a base 1 and a base 2. So the base 1 might be this lower base, and the base 2 might be the upper base. So it's just, remember these subscripts, just our names. First base, second base. So let's put our numbers in here. We're going to get the area is 1/2 times 7 feet times, now add those bases together, 8 feet plus 5 feet. So here's what I'm putting on my calculator. I'm going to put in 1/2. I'm going to put in as 0.5, and then times 7 times, now parentheses, 8 plus 5, but you can probably do that one in your head. And so when I computed that, I got this for the area. I got 45.5, and we've got square feet. So number 9, area of a circle. We've got a formula for the area of a circle. Area of a circle is pi r squared, and we're going to round pi. We're just going to approximate it using 3.14. So the formula says to take pi and multiply it by the square of the radius squared. Let's give that a try. So in this circle, we'll say that the area is 3.14 times the radius, 21 yards squared. So we know we raise powers first, so I'm going to get the area is 3.14. Now 21 times 21 is 441. Yard times yard is yard squared. And making that multiplication, we'll get 1384.74 square yards. But the book tells us just to round it off to the nearest tenth. There's the tenth, so just to the right is a 4, that's below 5, so we'll just drop it, and we'll write our area as 1384.7 square yards. So in number 10, we want to find the area of this circle. Now we're given the diameter, but our area formula looks like this. The area of a circle is pi r squared, where r is the radius. We're given the diameter, but we know this, that the radius is equal 1/2 of the diameter. So our radius here is going to be half of 10, so our radius is 5. I'll put these numbers in here. We'll get the area is 3.14 times 5 centimeters squared. And that multiplication gives me 78.5 square centimeters for the area of this circle. Well, now here in number 11, we want to find the area of this circle. And we're given that the circumference is 3 feet. Now, if you look back to number 9, we found the area of a circle with a radius given. In number 10, diameter was given, and now we're given the circumference. We're still going to use our area formula, which is area is equal to pi r squared, but we need to get out of this, we need to get r. So I need to look for a formula that has r and c in it. But we know this, we know that the circumference of a circle is 2 pi r, and I picked this formula because it has a c in it, and I'm given a c, and it has an r in it, so I can find r here. So let's plug our numbers in and see if we can get r. So we're going to get c, which is 3.00 equals to 2 pi times r. Now, 3.00 times equals 2 times 3.14 times r. 3.00 equals, now 2 times 3.14 is 6.28 r. Let's get r by dividing by 6.28. So we'll get 3.00 divided by 6.28. That's equal to r. And when I did that, I got 0.477 ... and so on. So I think what I'm going to do here is I'm just going to round to 0.48. Now, if I take this number for r and put it back into our formula way up here, we'll be able to get the area. So let's do that. So we're going to get I'll do it way up here. The area is equal to pi 3.14 times 0.48 feet squared. So I computed this one first, so I'm going to get the area is 3.14 times, I got 0.2304 square feet, and now multiply that result by the 3.14. All right, so when I did that, I came out with 0.72346. Oh, that's an interesting number, isn't it? Look at that, I like that. 2, 3, 4, 5, 6 square feet. but the book tells us just to round to 2 decimal places. So here's our 2 decimal places. That number 3 is below 5, so I'm just going to drop it. So all those will get dropped. So we'll write our area here as 0.72 square feet. I'll put the square up there too. So let's try to find the area of this figure here. Now it looks like a parallelogram, and what we could use, I guess, is just the area formula for a parallelogram. Why don't we just do that? The area formula for a parallelogram is base times height. That's going to give us the base. I'll use the 59 for the base and the 49 for the height. So we'll get 59 cms times 49 cms. And that'll give us an area of 2891 square centimeters. This looks like a square, right? These are all right angles. So I've got a square here, or at least a rectangle, but now I know it's a square because we're given this side here is 6 inches, and this side here is 6 inches. So they have the same measures, so it's going to be a square. And then we could write this. The area of a square, we could write the side squared, or we could use area of a rectangle, base times height. So the area is going to be, either way you do it, is going to be 6 feet squared, or if you like, 6 feet times 6 feet, right? Base times height, length times width. So what we're going to get here is 36 square feet, any way you do it. And now here, number 14, I think we're going to have to assume this is a rhombus. We're going to have to assume that these two sides are parallel. Otherwise, I don't know how we would do this. So let's assume this is a rhombus. So if we assume it's a rhombus, we have a formula for that, for the area. And the area of a rhombus, we've done one of these already, but we may remember it's 1/2 the height times 1 base plus the second base. So substituting our numbers in, we're going to get A equals 1/2 the height, which is 6 meters, times, say, the lower base, 1 base, 17 meters, plus the other base, 10 meters. So on your calculator, you may want to put in 0.5 times 6 times, now 17 and 10, you can do that in your head, getting a 27. And when we make that multiplication, we're going to get 81 square meters. In 15, we're going to build an addition to the house, and the addition is going to be rectangular in shape. And here's what we know. It might be 27 feet long and 14 feet wide. And the cost of roofing is $350 per square foot. So, how many square feet do we have in here? And then each square foot costs this much, so we'll just multiply 350 times this area. So we've got the area of a rectangle, which is length times width. So area for us is going to be 27 feet times 14 feet. And that is 378 square feet. And then the cost is going to be $3.50 times that number of square feet. So when I make this multiplication, I'm getting this. I'm getting that this cost for the roof is $1323.00. Now, let's just do this again as we did a few problems back. What we really have is this. We have $3.50 for 1 square foot. That's the price, right? The price is $3 per square foot. So $3.50 for 1 square foot times, and then we have 378 square feet over 1. And then what happens here is that the square feet cancel, and we're left with, now you can see it here, $350 times 378, right? So we get $3.5 times that 378. And that's just what we had back up here. We would have written that without the units. Let's find the area of the shaded region. So it looks like we're given concentric circles, right? I got an inner circle with radius 12 meters and an outer circle of radius 14 meters. So what if we did this? What if we think of it this way, that the area is going to be the, say, area of the outer circle minus the area of the inner circle. Okay, I'm just subscripting these, giving them names. I got the area of the outer circle, O for the outer circle. That'll give us all of that area, right? All of that region. And then subtract off what we don't want. That's the area of the inner circle. So we're going to get that the area is, okay, pi r squared for the outer circle minus pi r squared for the inner circle. So we're going to get the area is 3.14 times, now the radius of the outer circle is 14 meters squared, minus 3.14 times 12 meters squared. Well, this is going to give us 3.14 times, now 14 times 14 is 196 square meters, minus 3.14 times 144 square meters. And now making this multiplication, we'll get that the area is 615.44 square meters minus, making this multiplication, we get 452.16 square meters. And making that subtraction, we're going to get the area of that ring is 163.28 square meters. For 17, number 17, what's going on here is that Sarah buys this tabletop that is 10 feet in diameter. And the cost, so let's get this, the cost of the tabletop is it's $63 per square yard. Okay, so we can write that, we could write that as $63 per 1 square yard. So let's find the cost of the tabletop. So the cost of this tabletop is going to be the cost, right, the total cost is going to be the cost per square yard times the number of square yards. So you can see what we're going to need is the number of square yards. We already have this number, the cost. We just need the number of square yards. So the tabletop here is a circle, but we're given the diameter is 10 feet. We really want, in the formula, we want the radius, right? So the area of a circle, we know, is A equals pi r squared. So let's get this area to be 3.14 times 5 feet squared. So this is going to be the area is 3.14 times 25 square feet. And that brings the area to 78.5 square feet. But look what we're given here. This is the cost per square yard, and this is square feet. We need to get these units to be the same. We need to either need to get all square yards or all square feet. Now, one thing we do know is this, that there is 3 feet equal to 1 yard, and if we square these, we'll get 9 square feet equals 1 square yard. So let's make this conversion here. I think what I'll do is I'm going to convert square feet to square yards, and I'm going to use this as my converter. So we're going to get, just doing it like we've done before here, we're going to get 78.5 square feet over 1 times, now I want to get rid of the square feet and I want yards to be our end result. So I'm going to put the square feet on the bottom. So over here, let's put the square feet on the bottom. So we'll get 1 yard, 9 square feet. And doing that, the square feet will cancel, and we will get 78.5 times 1 yard over 9, which is, I'm going to round it off here, I'm getting 8.7 and then a bunch of 2's. But let's just say what we get here is, that's a square yard, so square yard. So our total cost is going to be $63 per 1 square yard times 8.7 square yards. And then, in this case, the square yards are going to cancel, and we will have 63 times 8.7, and that comes out to be, all right, we're left with dollars, 548.10. Now what's going on here is this, is that if, this is what I'm getting right here. Now, I rounded this number off. If I didn't round it off, if I kept some of those 2's, I would have this. $63 times 8.7 and then put a couple of 2's in there. So it might look like this. 63 times 8.722, maybe I write a couple of 2's. And then what I get is this. I get 549.4999. So what we could say is that it's $549.50. So it really just kind of depends on where you round off. So in our last problem here, we've got this figure here, and we want to find the area. Now, here's what I'm seeing. I'm seeing a rectangle, and I know it's a rectangle, or actually a square, right? Because it's 12, 12, 12, and probably 12. So it's a rectangle plus a triangle. So I'm thinking I can get the area, the total area, if I do this. Find the area of the rectangle and add the area of the triangle. So the area of the rectangle is going to be the length times the width, right? Length times the width. That's just going to be 12 meters times 12 meters plus, now we've got a triangle. This is going to be 1/2 the base times the height. So it's going to be 1/2. Now, what's the base? Here's the base. That's just this side right here, right? That's a 12. So 1/2 times 12 meters times the height. And the height is right here. That's 7 meters. So we're going to get 12 meters times 12 meters is 144 square meters plus, now, over here, 1/2 of 12 is 6. 6 times 7 is 42. So we'll get 42, m times m is m squared. And then adding those together, we're going to get 186 square meters.